Welcome back, students. In this video we are going to discuss the delete operation or dequeue operation on queue using linked list. Now deleting means what? Right? Deleting means if we have a node, I want to delete this node means what? Right? I'll retrieve the value of this node, store the value of this node in, let's say, x is equal to, let's say I have pointer p1 pointing here, x equal to p1 arrow data. I'll get this value out of this node, right? Extract the value and store it in, let's say, x. Then what will I do? I'll free the memory of this node by saying free p, and then I'll return the deleted value, removed value, by saying return x. So deleting a node means from the node getting the value, right? Extracting this value. What is the name of this field? This is data field, data, right? So p1 arrow data, because it's inside the node pointed by, or inside the structure pointed by p1. So p1 arrow data will give me 10. I'll store this in x variable. Then I'll remove or free this memory which is occupied, which we are holding, or which we are owning. I want to free that memory by saying free p. There is a function called as free. So this free p will free the memory pointed by p, pointer p1. Sorry, here we are using p1. So free p1. So this will free this memory. So this node is deleted for us, and then I'll return the deleted. That's what I want to. Now there are again two situations. The first situation is this one, where there is only one node, and there are many nodes. Many means more than one. Many nodes means more than one node in this queue. Now if I delete the only node from the queue, what will happen? If I delete this node, what will happen? The queue will become empty. So I should, when the queue becomes empty, f and r will be null. So f and r will be set to null. They will not point to here, they will set to null, and this is called as initialization of the queue. Setting f and r to null means initialization of the queue. When I delete the only node from the queue, I'll reinitialize this queue. That means I'll set f and r to null, right? So that is the first situation or scenario. What is the second scenario? Let's see that. What is the second scenario? This is the second scenario where we have many nodes. Now from which end we will delete? From which end we will delete? We'll delete from the front end. So this node is going to be deleted, right? Of course, when I delete this node, I need to take a pointer here. Let's say p1 in this case. I took p1, I got the value of a data field of this by saying x is equal to p1 arrow data, right? And then I said free p1, right? Free p1, and I'll do this here as well as here. In both places I'll do this. In both scenario, first I'll take a pointer to the node to be deleted, right? From front end. How will this p1 point here? P1 equal to f. Wherever f is pointing, if the queue is not null, right? Of course, the one more scenario is queue is null. In that, like this scenario, right? Queue is null. Queue is null means f and r. But we have made sure before calling this delete function, we have made sure that the queue is not null. Then only we are calling this. That's why I did not discuss this. The queue null scenario. I am calling deleting. I am calling delete function only after making sure that the queue is not empty. So if not empty and queue, I am calling x equal to dequeue and queue. So I am making here itself, I am making it sure that the queue is not empty. That's why I'm not going to discuss this situation. I'm discussing only these two situations. In both situations, I'll have a pointer p1 pointing to this node, which I want to delete. And which node will be deleted? The queue is not full. It's either containing only one node or many nodes. So in both situations, I will have pointer p1 pointing to the node where f is pointing, right? Wherever f is pointing, because I want to perform deletion from f end, right, by using f. So p1 will pointing to f1, P1 is pointing where F1 is pointing, so P1 equal to F. I'll do P1 equal to F, and as this F is not directly accessible, it's inside the pointer. Let's say if we have a pointer P pointing here, pointer P pointing to this node, so I'll say P arrow F, P arrow F, P arrow F, right? So what is the whatever the value of F is, of course the value of F is nothing but the address of some node. So that address of node is given to P1. P1 will pointing to a node where F is pointing, right? In this case this node, in this case again this node, right? So P1 equal to F, I'll say. Then first I'll extract the value of this data field of this node by saying P1 X equal to P1 arrow data, right? P1 arrow data, I got the value, right? And then I want to check whether the node which I am going to delete now is the only node in the queue, right? Is the only node in the queue, or are there many nodes like this, right? So these two situations I am exploring now. If this is the situation, right, I'll check this. If I will come to know whether there is only one node in the queue. If F and R are pointing to the same node, that means the value of F and R is same. F is pointing to this node, R is also pointing to this node. So that means there is only one node. If P arrow F, why P arrow F? Because I am accessing F by using this pointer P, and I am accessing R by using this pointer P. If P arrow F equal to P arrow R, right, that means there is only one node, and I'm going to delete this node. I'll reinitialize this queue by, that means I'll set F and R to null. I can call init function from here, initialize function from here, or I can directly set P arrow F equal to P arrow R equal to null, right? The same thing can be done by using initialize function also, right? Okay, and then I'll say free. After setting these to null, now I'll say free P1, free P1. That's it. This is the scenario. I'll do this. Else means this scenario. In this scenario, what I'm going to do, I have again done the same thing. What this thing I'll do here also, but this if is not true now. That means if F and R are not pointing to the same node. F is pointing to this node. That's why, and R is pointing to this node. That's why the value of F is address of this node, and the value of R is address of this node. Here also I have P pointer pointing here, right? So value of F and R is different, so this condition will fail here, right? If this condition fails, what I'm going to do, right, let me show you in else part of this, what I'm going to do. I'm going to this is going to be my next node, right? This is going to be my next node means first node in the queue, then, because I'm going to delete it, right? So this F pointer which was pointing here will point here. F pointer which was pointing here will point here, and then I'll say free P1, and then of course return X I'll do, because I have stored the value of deleted node in X, right? Data of deleted node in X, I should do that also, right? So but this pointer in else I'll do this pointer manipulation. What is that? So F P arrow F is equal to this node's address, and who is holding this node's address? Here, right? And what is the name of this pointer? Next, and it is inside the node pointed by P1. So P1 arrow next, right? So P1 arrow next is holding that is this value is address of this node. So I want to give this value to F. That means F will point here, and P arrow F, right? And then I'll simply say free P1 and return X. That's it. Here also I'll say return X. After free P1 I should say return X, right? So that is, these are the two situations, two cases. So let's write the complete code for this delete. Now here this is int dq. To this dq we are passing the address of the queue. That's why the pointer is struct q star P, right? So I'll declare a variable here int x. In x, this situation, remember, right? So this is the q, this is the q, right? Q's address we are passing. So Q's address, I'll have a pointer P here pointing, right? I'm passing. So what is the call? I'll write the call also, right? So the call will be x equal to dq. I already showed you dq and q comma only this much, dq and q. I'll pass only the address of q. So the address of q is there in P. So this was q f r. Now when I pass the address of this q, I will have P pointing to this q, right? So I need a pointer P1 here, struct node. Now this is node type pointer because I need a pointer pointing to the nodes of the queue, like this. So F is pointing here, R is pointing here, let's see. Right. So this is the queue. So I need a pointer pointing to the node which I want to delete. Of course, the node pointed by F will be deleted. So the type of pointer will be node star P1. Right. This P1 I need, and this P1 where should I point P1? Where F is pointing. F is pointing to this node. So P1 will also point to this node. So I will give P1 the address of this node. And who is holding the address of this node? F. But F is not directly accessible to me. I have to go through P. Right. So P, because P is holding the address of this queue. P is a pointer to this structure. So P arrow F is giving access to F. And where it is pointing P arrow F? Here. So that address I want to give to P1. So P arrow F. So now P1 is pointing here. So I'll retrieve the data from that node by saying x equal to P1 arrow data. Right. So I did this. We saw that this situation, right? This one, this part, right? Okay. So we retrieve that data. Then I should check whether the node which I'm going to deleting is the only node in the queue or there are many nodes in the queue, right? So I'll check that by saying if P arrow F equal to P arrow R. That means if F and R are same, they are pointing to the same node, the node which I'm going to delete is the only node. In that case, I should set F and R to null. P arrow F equal to P arrow R equal to null. Or I could have also called initialize function initialize by passing P, right? P is holding the address of the queue which we want to initialize. I'll call this function, this will do the same thing. And after doing this, after setting these to null, I'll say delete the node pointed by P, delete this node, right? By saying free P, and then return the value which is there in X, return X, right? This part. In else, I'll write else here. This is my else. Else means there are many nodes. This is the situation in many nodes. Now in this case, what should I do? This F will no more point here, but it will point to the next node. Next node is, address of next node is stored here, right? In P1 arrow next, right? So P1 arrow next is the address of this node that I should give F, so that F will point here. So what I should say, P arrow F equal to P1 arrow next, right? That's what this line will create this link, and then I should say free P1, free, here also free P1, I'm sorry, not P, free P1, here also free P1, and then return. Once I create this link, I will free this memory pointed by P1, free P1, and then I will return the value of X, which is there. X is storing the data of this P1. Return x semicolon. Actually this is semicolon. So this is semicolon here. Okay. And this is the end of the function. So this is the code to delete a node from the queue, or this is the dequeue function by using queue implemented using linked list. So this same steps we saw here, right? So this is a complete dequeue function, right? I hope you understood the code. So in next video we'll see the complete code for this queue implementation using linked list. So stay tuned. Thank you so much for watching.